Hi guys, we're going to go ahead and take a look at graphing cubic functions using roots. Remember that roots are the same thing as the x-intercepts or zeros. They're also known as the solutions. And we're going to take a look at the end behavior. Okay, and the end behavior is going to have a lot to do with the parent. So the parent for a cubic function, okay, is x cubed. All right, and the ends on the left is going down, and the end on the right is going up. Looks like that. Okay. So if it's a positive, okay, then it's going it's going down on the left and up on the right. If it's negative, we have a reflection over the x-axis. And in this case, instead of going down on the left, it would go up on the left and down on the right. Okay? So let's go ahead and take a look at a polynomial function. This is a general form of a polynomial function. Remember, poly means many. So we have many terms. So for example, here we have 1, 2, and then a whole bunch of them, 3, 4, and probably a whole bunch more in between. But as an example underneath, I put down an example. So a sub n is just your coefficient. So 10. X to the n. N is the degree of the polynomial. That's the largest exponent. So in this case, it's 4. Then the next coefficient, 7, x. And then notice it's going down by 1. So it went from 4 to 3 to 2 to 1. And then our constant always goes on the end. So this is a 4th degree polynomial. There's 1, 2, 3, 4, 5 terms, okay? And since it's a 4th degree polynomial, that's an even number. So it's going to resemble a quadratic equation. And because this is a positive coefficient, the end behavior is going to be up on the left, and it's going to be up on the right. Now that's not the right graph for that parent function. It would have gone through 0, 0. But the point is it's going up, up. Up on the left, up on the right. If there's a negative on the front, it would go down on the left and down on the right. So if there was a negative on here, we know that the end behavior would be negative and negative. If it's a positive, up, up. Okay, that's for an even degreed polynomial. Even degree. Odd degrees over here. So for example, if we had a polynomial that went like this, y equals negative 5x to the third, and then the rest of it. So we know it's an odd. Actually, let's make it a different number. Let's make it 13. So 13 is an odd number, so it's going to resemble one of these. Notice it's negative on the front, so it's going to resemble this. Up on the left, down on the right. If it was positive, okay, then it would resemble this positive coefficient behavior. So that would be down on the left, up on the right. All right, let's look at some problems. It says determine the degree and roots of each polynomial. Use your graphing calculator to help you sketch the graph. No y-scale. Okay, so first of all, for number 1, first of all, x times x is x squared. So the degree of this polynomial is going to be 2. Okay? X times x is x squared. It's positive, So it's going to go up on the left and up on the right. Even degree positive, up on the left, up on the right. So since it's quadratic, I'm going to go ahead and find the roots, not with my calculator. I'm just going to set each factor equal to 0. So I'm going to have a root at 2 and a root at -3. So it's going to go up on the left and it's going to go up on the right. So remember, you are graphing the roots and then you're using the degree to determine the end behavior. Okay, so let's take a look at this one. So here we have x times x minus 4 times x minus 4. So we can set each factor equal to 0. So we're going to have a root at 0. We're going to have a root at 4 and another root at 4. So this is a double root. Okay? So a root at 0 and then 1, 2, 3, 4. So if we do x times x times x, we get x cubed. So it's positive, so it's going to resemble this one. So down on the left, up on the right. So down on the left, up on the right. Alright, so now to draw this, now yes, you can use your calculator to help you out. So this is a single root. So remember, single we cross, and this is a double root. So double roots we bounce, or just touch. This is a single, because there's one of them. This is a double, so we have, it just touches it, or it just bounces off of it. Back over here, these were both single roots. So it crossed, and it crossed. Okay? All right, let's take a look at this one. So here we have negative x minus 2 cubed. Let's go ahead and do this one on the calculator. And if I can get this to show up a little bit better, we might be in business. Doesn't want to. It's not even wanting to zoom in and zoom out. Well, what am I going to do here? I can't get the calculator to... Here we go. Here we go. Okay, so I learned something thanks to Keegan. Okay, that I'm on my scratch pad right now, and if I press this button right here, I can change it from the calculator mode to the graphing mode. And again, I don't have a very good focus here. There we go. So right now I'm in calculator mode. I want to delete that, so he's told me to press dock, then arrow up one, and it says clear scratch pad. So it takes me back to the calculator, press the scratch pad. Now I've lost my calculator again. Okay, let's plug this in. So negative x minus 2. And I lost it again. Raised to the third power. All right, and then we can graph this. Press enter. So notice it goes, so notice that the x minus 2 occurs 3 times. So we have x minus 2 equals 0, x minus 2 equals 0, x minus 2 equals 0. So we have x equals 2, 3 times. That's a triple root. Triple root. Okay? That means it doesn't cross, it doesn't bounce. It's wiggles is a good word for it. It wiggles. When it's a triple root, it wiggles across the axis. It's also called a saddle point because it looks like you're sitting on a horse and you're sitting on a saddle. So at 2, 1, 2, okay, so notice it's negative, it's odd, so we're going to the odd function, okay, and it's negative, so it's going to go up on the left, down on the right. So it's going to go up on the left, down on the right. And it's going to wiggle, so it's going to kind of come down and flatten out through that point and then come down like this. And again, that's called a saddle point. And it matches up on the left, down on the right. Okay? So, number 4. Notice x squared. That's going to be, that's 2 x's. So that means we have x times x minus 4. And we got a negative out front. So x times x times x, we have an x cubed. And it's negative. So it's going to resemble this one. Okay, up on the left, down on the right. So this root is going to be 0 because remember we set each factor equal to 0 to get our roots. So we got a root at 0 and a root at 4. Okay, this is a double root, so remember it's going to bounce. This is a single root, so here it's going to cross. So back up here, it's negative, it's going to be up on the left, down on the right. So we're going to go up on the left, down on the right. So again, this is a double root, so it's going to bounce. This one's a single root, so it's going to cross. So let's go ahead and turn that back on. Let's tab. I want to get rid of that. So dock, up, clear scratch pad. Let's press scratch pad and let's plug it in. All right. So we have negative x squared times x minus 4 and enter. So see, notice it's not perfect, but up on the left, down on the right, it bounces and then it crosses. Okay, so we got just about a minute left. And so just some information about graphs of polynomials. Graphs of polynomials are smooth. Okay, there's no breaks, gaps, holes, or sharp turns. So for example, that, which is y equals the absolute value of x, is not a polynomial. There's a sharp turn. Polynomials, graphs of polynomials are smooth. Okay, just like our x cubed function. The end behavior of the polynomial will be same as the power function of the same degree. So remember, if it's even, it's going to resemble a quadratic, a parabola. If it's odd, it's going to resemble a cubic on the ends. A polynomial of degree n has most n roots. So if I have y equals x to the 5th,